Framework Pluto was the main Kuiper Belt object found, and we didn't find any other for something like 60 years. On November 2, 2015, the globe accepted its first look at a thing from the Kuiper Belt. It was one of the most amazing photographs from space disclosed yet. That has simply changed. The James Webb Telescope has recently gotten the most detailed picture of the Kuiper Belt in history, and it's nothing similar to what anybody envisioned it to be. The Kuiper Belt is situated in the outer planetary group and creates a bone-chilling, donut-formed region. It sits past the orbit of Neptune, the eighth planet from the Sun. At first, its shape was the most intriguing thing about it. However, it then became clear that this would have been the most fascinating aspect of our planet. The Kuiper Belt is named after cosmologist Gerard Kuiper, whose work in the mid-20th century laid out the system for figuring out the area past Pluto. However, he wasn't the person who found it. In 1951, Kuiper introduced a logical review that emerged about the presence of things past Pluto. Kuiper's research essentially centered around the probability of things being past Pluto, yet it didn't make complete predictions regarding the specific highlights or organization of the articles within this locale. Pluto was previously viewed as the defining part of the Kuiper Belt, but it's presently recognized that Neptune's orbit, as opposed to Pluto's, makes the inner boundary of the belt. The gravitational force of Neptune has assumed a significant part in defining the dynamic of the Kuiper Belt. Despite the fact that Kuiper's predictions were not directly aligned with the discoveries eventually made in the Kuiper Belt, his pioneering thoughts and accomplishments were profoundly known among astronomers. Over time, the overall concept of the Kuiper Belt and its relationship with objects past Pluto became attached to Gerard Kuiper. In 1930, astronomer Clyde Tombaugh discovered Pluto in what we now know as the Kuiper Belt, making it the first during its discovery. The understanding of the outer planetary group was limited, and astronomers didn't anticipate the presence of a significant population of frozen worlds past Neptune. The prevailing conception of the solar system includes the inner rocky planets, the gas giants, and the outermost frozen giant Neptune. Pluto's identification, despite its eccentric and tilted orbit, led researchers of the time to regard it as a solitary planet. It was only 62 years later, in 1992, when the second Kuiper Belt object was found. At this point, it was obvious that Pluto was not a singular entity but part of a greater population of objects in the outer solar system. The subsequent discovery of various KBOs, Kuiper Belt objects, confirmed the presence of the Kuiper Belt, a region housing a diverse array of cold worlds past Neptune. Pluto's significant importance in cosmic history lies in its initial classification as the ninth planet, a title it held for many years. However, as our understanding of the Kuiper Belt evolved, and with the finding of new KBOs, especially those with greater dimensions than Pluto, the International Astronomical Union updated the criteria for planetary status. In 2006, Pluto was then named a dwarf planet, but it will always remain one of the most important discoveries in our solar system. Without it, we would have never explored the region of the Kuiper Belt. This unique area is viewed as an extension of our solar system since it is part of the same cosmic region and is influenced by the gravitational forces of the Sun. While the 8 major planets, including Neptune, dominate the inner solar system, the Kuiper Belt extends the boundaries of the solar system into the outer regions. It is unique from the inner solar system and is characterized by an assortment of icy objects, including dwarf planets, asteroids, and comets. According to NASA, the material in the Kuiper Belt is believed to be remnants from the early solar system, dating back around 4.6 billion years, and is expected to have preserved conditions and materials from that time. Within this belt, we have Pluto and its moons, as well as additional dwarf planets like Haumea, Makemake, and Eris. The Kuiper Belt is also home to a diverse collection of small icy bodies. It's a specific part of the solar system that we don't fully understand. The Kuiper Belt is considerably larger than the asteroid belt, which is a collection of rocky objects, predominantly asteroids, lying between the orbits of Mars and Jupiter. It is relatively thin and contains a vast number of small to medium-sized bodies. On the other side, the Kuiper Belt is a more massive and remote region. Most of the Kuiper Belt is estimated to be 20 to 200 times larger than the mass of the asteroid belt, indicating that the Kuiper Belt includes a more significant amount of material, both in terms of the number of objects and their overall mass. That's part of the reason why it was so surprising that this discovery took such a long time. Initially, the fact that it took some time for the find to be made doesn't mean that this place isn't fundamental to the solar system. It's home to a wide variety of celestial bodies, including dwarf planets like Pluto, Haumea, Makemake, and Eris. Pluto, discovered by Clyde Tombaugh in 1930, was initially viewed as the ninth planet until the International Astronomical Union updated planetary models in 2006, resulting in its reclassification as a dwarf planet. Pluto, with a diameter of approximately 2,377 kilometers, orbits with other notable dwarf planets in the Kuiper Belt. Study into Pluto has also helped researchers and scientists better understand this distant region. This was just the beginning, though. Haumea, discovered in 2004 by a team led by Mike Brown, adds to the Kuiper Belt's diversity with its distinct elongated shape, likely a result of rapid rotation. This dwarf planet, roughly 1,960 kilometers in diameter, has offered us a lot of information on the intriguing properties of Kuiper Belt objects. Another discovery by Mike Brown's team in 2005 shows its own curious characteristics. With a diameter of approximately 1,430 kilometers, Makemake lacks a large atmosphere, but its bright surface, featuring methane, ethane, and tholin, characterizes it as one of the brightest objects in the Kuiper Belt. Eris, also discovered in 2005, is somewhat smaller than Pluto but more massive, with a diameter of approximately 2,326 kilometers. Eris is a significant member of the Kuiper Belt, and its discovery contributed to the reevaluation of the concept of a planet and expanded our understanding of the variety and dynamics of objects within the Kuiper Belt. Together, these dwarf planets provide vital insights into the formation and evolution of the Kuiper Belt and its role in the broader context of the solar system's history. Without them, we would be entirely in the dark about the region. A lot of people throughout the world have confused the Kuiper Belt with the Oort cloud, but what they don't realize is that the Kuiper Belt is more densely populated with objects and is expected to be a source of short-period comets that have significantly shorter orbital periods. On the other side, the Oort cloud is a much more distant and spherical region that envelopes the entire solar system. It is believed to range from around 2,000 to possibly 20,000 astronomical units from the Sun. The Oort cloud is made of frozen bodies, frequently compared to dirty snowballs, and is the suspected source of long-period comets with highly elliptical orbits that bring them closer to the Sun. While the Kuiper Belt and the Oort cloud are different in areas and shapes, they share the common quality of being reservoirs of frozen bodies. Both are considered potential sources of comets, cosmic objects made of ice, dust, and volatile chemicals, which become visible as they approach the Sun, and the solar wind drives them to develop a bright coma and a tail. So the confusion can make sense sometimes, but grasping the differences is crucial. Something about this place that has scientists alarmed is that the amount of material in the Kuiper Belt today might be just a small fraction of what was previously there. What we have today are directly just remnants, and the genuine stuff has long vanished. But this wasn't random. The NICE model is a theoretical framework that suggests a sequence of significant orbital changes in the outer solar system, particularly involving the four largest planets: Jupiter, Saturn, Uranus, and Neptune. According to it, the giant planets in the outer planetary group did not always occupy the same orbits they do today. Rather, they underwent a period of rapid orbital change. The hypothesis argues that interactions between these giant planets led to dramatic changes in their orbits. As a result of the altering orbits of the giant planets, the NICE model predicts that a significant amount of material in the Kuiper Belt, initially estimated to be 7 to 10 times the mass of Earth, may have been lost. The gravitational interactions and changes in the orbits of the giant planets could have caused material in the Kuiper Belt to be scattered, ejected from the solar system, or moved to different locations. Due to what's happening, the Kuiper Belt is currently in a state of constant erosion. Collisions between objects within the belt can cause fragmentation, leading to the formation of smaller Kuiper Belt objects. Some of these smaller objects may become comets, while others won't. However, what doesn't become a comet is pulverized. The dust created by impacts can be blown out of the solar system by the solar wind. The overall mass of all the material in the Kuiper Belt is estimated to be only around 10% of the mass of Earth. That can make it seem small, but it's still an extensive number of Kuiper Belt objects that have been found to have moons. These moons are smaller entities that orbit around a larger parent object. This phenomenon is not confined to planets but extends to numerous objects within the Kuiper Belt. So what does the Kuiper Belt have to do with our lives? It's important because the ongoing research on this remote region has the potential to unveil insights into the formation of. Research helps scientists understand the distribution of volatile materials and their role in the development of planetary atmospheres and potential habitats for life. Understanding the composition and characteristics of Kuiper Belt objects informs models of planetary formation and the dynamics of the outer solar system. They serve as a natural laboratory for studying the processes that govern the creation and behavior of celestial bodies beyond the orbit of Neptune. Finally, the investigation into the Kuiper Belt can advance our knowledge of how celestial bodies evolve over time, providing valuable comparisons to similar regions around other stars. The insights gained from studying Kuiper Belt objects can enhance our comprehension of planetary systems beyond our solar system. To many people, the Kuiper Belt is much more than a region of icy remnants. It holds the secrets of our solar system's past, the processes that have shaped it, and the dynamics that continue to influence it today. Its importance goes beyond its location and composition. It plays a critical role in advancing our knowledge of planetary formation, the distribution of materials, and the broader cosmos. Understanding the Kuiper Belt is vital to unlocking the mysteries of our own origins and the intricacies of the universe we inhabit.